Good morning, fellow programmers. Thanks for joining me. I'm T-Pain, and welcome to Let's Learn Python. Feel free to use the skip ahead feature on the right-hand side to jump to any specific sections. Today we'll be using Python 2.76 and Python 3.4.2. You can download those from python.org/downloads. Today we'll be focusing on how to launch a horse into space. This has never been done before. Horses have never been above the stratosphere. So what I'm going to teach you is how to actually get that horse into space and to make Space Horse. Space Horse. Terrible joke. All right. So today we're going to be focusing on the solutions for lessons 9 through 16. We're going to be going through the final challenges at the end of each video and answering them one by one. In the description of this video, I'll be providing a link right here that'll take you to GitHub to download the files. Once you click on that link, it'll send you to this page right here. You can download them from the right-hand side where it says download zip. And you'll be provided solutions for problems 09 through 016. And here will be the files that you download from GitHub. So let's go ahead and open up 09. Okay, and shrink that text down from a ridiculous size. And the final challenge is in the script, change the extension from txt to something else. Okay, and we did just that. The answer to part A is right here, and you'll notice this little comment. And what we're doing is we're just changing it from .txt to .html. Okay, next part says change script to store some text in the file. And the way we do that is with the write function. So here we open the file up. Here we're going to actually write words to that file, and words is going to contain. And here in words we're actually going to write out, you know what this file could use? And then after that, we're going to print out ham times 50 because you can never have too much ham. Okay. And then finally, the last part of the challenge is to create a loop that creates 5 different text styles of different names. And so all we're doing is we're doing that right here, and we're just adding a 01, 02, or whatever the number is with a few zeros in front of the file number. Okay. So let's go ahead and save this and let's run it. And it just prints out done once it's finished. And so now if we go back to our folder, which has all our files, we'll now have these files that are all HTML. And we can double click to open any one of them, and it'll just be an ugly HTML page that prints out a whole bunch of hams and text. Yeah, really basic HTML file. Okay, let's close that back down and go back to our folder. And so that's it. I'm gonna go ahead and delete those files because we don't really need them. Bam. And that's it for this challenge. And now let's look at the final challenges for lesson number 10. So the next challenge is a bit more complicated. First, it asks for us to create an inheritance tree with the following structure. We have a base character class, we have a non-playable character class, a friendly enemy playable character, and so on and so forth. And let's go ahead and crack open the file and see what it looks like. Okay, so for the first part, it says ask for a base character class. So I created that right here. This class is the one that's going to be inherited by pretty much all the other classes. And they're all going to go build off each other hierarchically. So next we have the non-playable character class, and then the friendly and enemy non-playable character classes. Another way to say non-playable character is NPC. So I shortened it up and said NPC friendly, NPC enemy. And notice that they're both inheriting from the appropriate classes. And since we're just actually creating them, we don't have to store anything else in them. We could just use the keyword pass to actually say, hey, we're not going to pass anything else, to make it a blank class. And below that, we have the playable character class. It's just very simple implementations of those characters. Next, we have to add a function that says print name that all characters have. So the best way, since all characters have to have it, we're going to go to the base character class and add it there, which we did right here. So that's the answers to part 2. Part 3 is asking for all enemies to have an attribute of attack damage equals 5. Okay, so then we go into NPC enemy, and then we add that in by using the constructor in it, and then creating an attribute called attack damage, and assigning it a value of 5. Next, we have create a weapon class within the same file. So create a weapon class, simple class right here, on line 24. And notice that we do inherit from objects so that it can be inheritable if we do create any specific weapons like a bow or a gun or whatever it may be. The final part of this challenge is to have all PC characters start with a weapon. So all playable characters need to start with a weapon. So scroll down here, and here we have all of our playable characters. But since we want all of them to have a starting weapon, then we're just going to assign it to the base playable character class right here and implement that in the constructor. Boom, done. And down here, we're actually just testing out the file to make sure that it runs properly and printing out the outputs to make sure everything works correctly. So if you run this in Python 2.7 or Python 3 and above, it'll work just fine. So we'll just press Control V and test it, and there's our stuff. Perfect. Okay, let's move on to lesson number 11's final challenges. Okay, so I'm gonna go ahead and close down this file, and I'm gonna open up file number 11. Now this part actually has two different files. This has the base file and then the classes file. I'm gonna go ahead and open up both of those. Let's open up the base file first. So in the final challenges, it says create a base class with a variable x equals 5 and a function called printham that prints ham, and in a file called base.py. Now, rather than making it that file name, I actually just added sol underscore 11 just to make sure that we knew it was clear that these two were bound together under the solution for 11. Okay, and here we do just that. We just create a variable for the class of x equals 5. And then we have a function called printham. Really simple stuff. Let's jump over to the classes. And in part 2, it says create an inheriting class that overrides x to be 17 in classes.py. Okay, so that means that we're going to be using the other file. So first we import it as base. And then since there's a class within there called base, it's going to be base.base to inherit from it. Okay, and then we just create the constructor. We override the value of x to be 17 instead. And then we're good. Part 3 says create another inheriting class, still inheriting from the base class. The override printham and overrides the printham function to printham2. Okay, so we just so that would be this part where it says better ham. And what this is going to do is it's going to create a function called printham, just like in the base class file right here. So we're going to be overriding that function with our own function, and then we just have printham2 there. And since we want to make sure that we have all the variables assigned to this class, we actually have to call the constructor of the base class. And the way we do that is with the function super, and then pass in the name of the current class, which is betterham, self, and call the init function. And then it's done. So number 4 says, finally, create a class which inherits from both new classes and print x and call the printham function. This is just to test out that everything's working properly. So we're going to go ahead and create a class called combo and have it inherit from both classes separated by a single comma. So then we have the constructor function, and then we're going to use it to call the constructor function of the inherited classes up above. Again, we use that super function. Finally, we want to create a single line of code that'll print out all the subclasses which we have that are inheriting from the base class. And the way we do that is by calling base.base underscore subclasses underscore and then open close parentheses. And again, that's 2 underscores, not a single underscore for that subclass function. And that's it. So if we run it, we get an output of ham2, 17, and then some other jargon. All right, that's it for lesson number 11. Let's move on to 12. Okay, so let's open up the solution for lesson number 12. This one says create an abstract base class called human and give it an abstract function called run. So the way we do that is we import the stuff that's going to allow us to create abstract functions, and then we create the class human. We make sure to have the meta class equal to abc meta, and then we make the constructor be an abstract method. This will basically stop it from ever being created. That you'll never be able to create an instance of human. Instead, it'll just lock you out. Then we have a function called run, which will be callable by inheriting classes down below, or subclasses. And there, something to note is that I found that in a version of Python, Python 3.3, that it was having trouble using this code right here. So I actually included some other code that you could use, which is commented out right here. So just comment out this line. So if you're using Python 3.3 or if you're having trouble running this code, just comment out these 2 lines right here, lines 6 and 7, and uncomment line 5. And that should allow you to run through this code properly. And the same goes for the robot class down below. So part 2 of this challenge, create an abstract base class called robot and create an abstract function called vacuum. Okay, so the code is pretty much the same as before. Part 3 is create a subclass which inherits from both human and robot called cyborg, because cyborgs are awesome. Jean-Claude Van Damme, woo! And creates an instance of cyborg. Okay, so down below we have a cyborg class that inherits from both human and robot, and then it calls the constructor functions of each of them using this super function. And scrolling down, here we have the code to actually test out these stuff in the file that we've created. Now, I included this. I included this exception handler to actually try to create instances of the robot and the human class. It should fail. So if we run that, it says could not create human, could not create robot. That's the code that we want to see. If you find that these two lines are not being displayed, it means that it's actually creating instances of those classes, which it shouldn't be. So again, you'd have to comment out these lines right here and replace it with the line up above on line 15 and line 5 so that the classes cannot be instantiated. Again, this is for Python 3 and above that you're going to need these lines of code right here. Next, we actually create an instance of the cyborg, then we call the function run and call the function vacuum. Okay, and it gives us an output of running and vacuuming. Awesome, because that's what I do whenever I vacuum. Alright, so that's it for the examples for lesson 12. Alright, so here we have the final challenges for lesson number 13. On the right hand side, the solution would actually be an image. Okay, so going through it, number 1, a bus driver has a bus. So right here on the left hand side, we have a bus driver, and then he has a bus. So we're going to be a diamond arrow pointing to the bus. Next, we have a bus has passengers. Now, I found the best way to represent this is to actually create individual instances of those passengers. So we have Bob, Sam, and Jess. And the bus would actually have all of these guys together. Bob is going to be human, Jess is going to be human, and Sam, unfortunately, is going to be a zombie. She craves brains. Anyways, so number 3, and the way we represent that is through a solid arrow pointing to whatever it is. So Sam is a zombie, and Bob and Jess are humans. Next, the bus driver has a relationship with the radio. So we represent that with a dashed line arrow pointing to the radio because he fell in love with his radio. All it took was one sweet call from an operation manager and he just fell in love with it. He's taken it to the coffee shop and he's paid for the date, and hopefully if things go well, maybe they'll get married. Okay, that's pretty tacky. Alright, so moving on to example number 14. Okay, so let's move on to the examples for lesson 14. Okay, and let's open up the code for 14. Final challenge is create a function that prints out individual elements of lists within lists. This was one of the more challenging challenges, actually. The first way that you could have developed this solution is by having it just straight go through and expect to only get basically a listception of one list within another. So the way we'd go through that is first we'd crack open the first list, and then we'd expect the inner item to be another list itself, and then we'd actually have the items being output there. So it's just going to go through the outer list, go through the inner list, and then print out each item there. However, this isn't a very good solution because what's to say if there's like 3 or 4 lists within each other? This would not be a good solution for printing out each individual item. So part 2 says repeat problem 1 by solving with recursion. So the way we're going to do that is we're going to have the function call itself somewhere within it, and it's going to be triggered by some condition. So this also solves for part 3 as well, which says repeat problem 1 using type your list is equal to list to just check to see if the current stuff that we're looking at is a list itself. First, we're going to check to see if the outer list has anything in it, if we're not being passed a none or a 0 value. And if that's met, then that means we can check if the object is actually a list itself. So if both those conditions have been met, it's like a full list and it is a list, then we're going to go ahead and iterate through it. And then we're going to check to see if that inner list is actually a list. And if it is a list with itself, then we're going to go ahead and call the same function and basically repeat the process of iterating through the next list to print out items. Otherwise, if the inner list is not a list, then we know it's an actual item, like a string or a number or something. And so then we're actually going to print it out. Okay? And so this is a much better solution than the one up above because it's actually going to be checking on itself to make sure that the objects are lists that it's iterating through rather than just blindly trying to force through it. Because if we pass in a string into this above function, then what it's actually going to do is going to break up the string and then try to print out individual letters, and so it'll just result in a very long output. So part 4 says repeat problem 1 through 3 for a keyword argument. So now we're going to combine all this stuff up above by actually using arguments and keyword arguments to figure out what's been passed in and to print out everything that's been passed in. So this will take unlimited arguments and unlimited keyword arguments. So we could assign a whole bunch of stuff. First thing we do is we actually try to iterate through all the stuff being passed in. Now what we're doing here is we're trying to convert the args, all args that are passed in, into a list. Because initially when it's being passed in, it's actually going to be a tuple. And then we're going to take all the keyword values, and if you're using Python 3 or above, then this will actually be a strange object. It won't actually be a list itself. So we convert that to a list as well. If you're using earlier versions of Python, then this won't do anything. You can actually take out this list conversion right here. It doesn't do any harm by leaving it in there though. So we're going to be going through every item being passed in through the arguments. And we're going to check each individual item to make sure it's a list, and call this recursively if it is a list inside of itself. So yeah. Alright, and then of course we need to test out all of our code. And I created a few lists. So the first one is just simple two lists within lists. Next we have like a more complex list. And finally the last one is we have tons and tons of lists within lists. And so then we test out each individual function and then print out at the very end your sexy beast. Because yes, we are a sexy beast. You in particular, you are one sexy beast. Alright, so let's go ahead and press Control B to run the code. And it outputs the first list items of 1, 2, 3, 4. Then it repeats it again, 1, 2, 3, 4, a whole bunch of times because we have it passed in 3 different times into this function. Then we have list 2 being outputted, which is 1, 3, and 5. And then after that, we have that huge long string, and it's outputting individual items, including a string without any values in the middle. So that's going to be result in a blank right here. Okay, and it prints out everything and says that you're a sexy beast at the end, which is a very true statement. All right. So that's it for lesson number 14. Let's go ahead and move on to lesson number 15's final challenges. So let's go ahead and crack open file number 15. Part 1 says create a function that returns ham, which is our favorite go-to right here with ham maker. Not prints, returns ham. So number 2 says create a function that adds sandwich, that's a space sandwich, to all functions that are passed in. So right here we have just that. We're going to use the functions within functions to actually add on stuff that's being added in. So here we are, right, line 8 with sandwich maker. So basically it's going to be passed in some function into the arguments, and then we put in the star args and star ky args to make sure that we take in any number of arguments and it doesn't crash the program. And then we have the sandwich maker inner, which simply adds space sandwich to anything that's being output from the sum function that's being called. And then we're going to just return that inner function that we created. Third, we're going to apply a decorator to the first function, and we're just going to create that decorator, pass it in to this guy right here. So this is hammaker2, which is basically just using the decorator method of binding it. And the way that we would actually bind together the two functions is down below in line 36 right here, where we say sandwich maker, we pass in the function called hammaker, and it creates our new function right here. So number 3, we just use the decorator method right here. Moving forward, number 4, we just repeat all this code right here, just basically copy and paste it down below, and just replace the names, and now we're actually going to be punching in float values instead of strings, adding them together, and to create a final float value. And down below we have our final code for testing everything. And so if we could press Control B, we'll see an output of ham sandwich, and better ham sandwich. And the second outputs are the float values that we passed in added together. Awesome! So that's it for number 15. Let's move on to number 16. Okay, opening up file 16. Number 1 in this challenge says create a singleton that has a function which returns a value that increases +1 every time it's called. So it returns 1, 2, 3, 4, etc. And the way we do that is we create a class that's auto increment singleton. Of course I can't spell, so this should be with an E, but whatever. So then it's going to be inheriting from object. We're going to set the instance to none. We're going to be using the first method that I explained in the tutorial to create this singleton. And that's just creating that variable underscore instance equal to none. When this whole class is actually going to be instantiated and created, we're going to see if there's one already in existence and return it if there is, and if not, we're going to go ahead and create one. And then lines 10 through 12 are what's going to actually satisfy the problem 1, which is we start with a value of 0 if the singleton has not been created. And then after that, we're just going to go ahead and go +1 every single time. And so anytime this new method is called, or we're going to create an instance of it, we're just going to go ahead and return that value +1. And part 2 of this problem says create a singleton that acts like a phone book. It has a function that you can pass in a name and number to store, and another function to retrieve a number given the name. Okay, and so we're going to do that down below right here. Now I actually wanted to implement the second method that I taught about how to create singletons. That's by creating a singleton function that'll actually store all of our singletons within a single dictionary in memory. And so if I wanted to apply this to any other classes, I could use this. So this is pretty much all code that we saw in the lesson before. And here I actually use this decorator to assign this class to become a singleton. And I have the creation of the phone book manager. So we have a function to add an entry, a function to get entry, and a dictionary in which we're going to be storing all those values. Really simple adding and retrieving values to a dictionary. That's all this class does. Minor note is that we have this return 00 in case there is an item that's called that does not exist within the dictionary. And down below we have the final code to test out the rest of our code. And this first part is just to test our auto increment singleton, which will, again, it'll create value 1, 2, 3, 4, and so on and so forth every time we call it. And then the code to test out our phone book managers. This line is to create the code, then we add an entry, and after that we create another instance of the phone book manager, but being as how it's a singleton, it actually just references the first instance, and then we are able to retrieve that entry from the dictionary. And so if we run it, we get an output of 1, 2, 3, which is the auto increment singletons, and then we get the 555, which is what we expected for the value of Timothy. I forgot about that. Alright, thank you so much for watching. Please leave me a comment below if this helped you at all. Please do me a huge favor and subscribe to my channel. It would really mean a lot to me. Also hit the like button if you want to show some love. And thank you so much for your support, and keep the dream alive.